Hello everyone, welcome to our session, Fileless Control, Removing the Backdoor in Backdoor Shell. I'm Abraham Camba from Managed Detection and Response Team from Trend Micro, and here with me is Gilbert Sison.
Hi, good day. My name is Gilbert, and I'm currently the threat hunting lead for Managed XDR team. And I am very lucky because I am able to do what I like to do for work, and that is to figure out how things work. So before we begin, just to scope out what we mean by backdoor. So the backdoor that we're referring to is the tool or are the tools that are used in targeted attacks. So the thing is, in targeted attacks, actors tend to be more precise. Their actions are more uh, focused. So they do a lot of research before they actually do the attack. And as a result of that, the tools that they use are mostly catered to the target. So in this slide, we have the 6 stages of targeted attack. And what we are interested in is the command and control and the lateral movement. So to be able to do command and control, the attacker needs to have some sort of control on one or more of the machines in the environment. So traditionally, they use a remote access tool or a backdoor. So these things, they just give some control to the attacker. So what it needs to have is, first, it needs to be able to communicate to the outside world. Ideally, attackers usually compromise a site, and these backdoors connect to that compromised site where the commands are uploaded. Second is, it has to be able to execute commands. And the newer backdoor shells that we're seeing use cmd.exe or command prompt. And that's where we got the shell part. And lastly, it should be able to execute other tools. Now, obviously, one backdoor infecting one machine will only give the attacker one machine to control. So if he wants to control multiple machines within the environment, he has to spread these tools all over the place. And to do that, he has to do some lateral movement. Now, this is a little noisy because his first option is maybe to use an exploit. But using an exploit means generating a lot of noise that would definitely be noticeable to the security team. So instead, what they usually use is the more subtle way of mapping a network drive, copying the backdoor, using that map drive, and then executing it through some means, like maybe calling wmic.exe or setting a scheduled task remotely or setting a service, so on and so forth. Now, the problem with this is that it is noisy. So the backdoor itself is noisy. There is a file involved that your EPP can detect. The steps that need to be taken to move the binary from one machine to another generates a lot of noise that in EDR times, or nowadays, can easily be detected. So, is there a way to remove the backdoor shell and be more stealthy?
Yeah, is there a way to remove the backdoor shell and be more stealthy? Actually, there is. It's a very simple solution, actually. You could actually live off the land. So living off the land is actually a concept of using existing tools within the system, like for example CMD, PowerShell, or Reg SVR, and these are actually pretty powerful tools. And the good thing is they are already embedded in the system. And since they are already embedded in the system, probably it's easier to remain under the radar because most of the detections in place wouldn't detect those tools. Yeah, and one of the living of the land tools that you can use is actually SMB, which is server message block. You probably know this mostly for file and printer sharing. It uses port 445 and probably it's open by default in your machine. And what you probably don't know is it could actually be used in authenticated inter-process communication mechanism. Uh, for example, you could actually use SMB uh, in executing Psx. If you're familiar with Psx, it's part of Windows Sys internal and mostly used by IT admins for deployments and remote administration. And it actually uses SMB to remotely execute commands. To illustrate further, I'll be sharing what happens in the remote user side and the host side. So basically, in the remote user side, you execute psexec using the IP address or the host name as parameter, and also the username and the password. And as you can see on the right side, you would see that the remote user actually had access to cmd.exe as if he is already on the host machine. And on the left hand side, you could see what happens in the host system. In the host, you would see a Psx Service that's running CMD. And all the commands from the remote user is actually uh, piped or forwarded to the cmd.exe on the host side. And a remnant of PSXX is actually a service called Psx Service. So this is a permanent service actually, and the downfall for that is it's actually quite noisy since you would be able to detect it easily since there's a remnant. Also, PSexec is usually for internal use, so you need to be able to have the credentials in order to use it. And one of the downfall, as I mentioned earlier, is probably it sticks like a sore thumb, since you would actually see a service called PSX Service, so it's not really that stealthy. And the mitigation for it is actually simple. You probably just disable it in your application control if you're not an admin. So given that, probably I will introduce another tool called SMB Exec. So SMB Exec, if you're not familiar, is a tool that works like PS Exec but without uploading any binaries. As you can observe earlier, we saw that there's actually a binary uploaded here. PSXX actually requires itself to upload the binary that would be the bridge to the shell. But for SMB exec, there's no need to upload a binary. So no system artifacts would be found after command execution. And it actually looks like this. So we have a remote user by using the SMB exec Python script from Impacket framework, and if you have the credentials as well as the IP or host name, so it's pretty much straightforward. You just execute the script, input the parameters, and then you would actually have a shell. And if you look closely at the left hand side on the host machine, you couldn't actually see anything running. Unlike in the PSexec uh, earlier, you would see a binary called Psx Service. But for SMB exec, there's actually nothing. Uh, the reason for that is for the remote user, this is actually just a pseudo shell. So nothing is executed yet on the host machine. But once the remote user decided to perform a command or execute something, for example, for this case, it's a ping. So you would actually see something in the host machine. You would see this one. So a cmd.exe is executed with the ping command. And and if you observe closely, the command line is actually a very peculiar command line since a lot of things are being piped. And at the end of it all, the executed command is actually being deleted. So you would see there execute that bat is executed and deleted right afterwards. So what would it look like on the host machine? How would you actually detect it? On the host machine, if you review the event logs from Service Control Manager, you would actually see a service created by SMB Exec. So in this case, the service name is bto with a service file name. However, if you query this service using se.exe, if I query this service, it would actually give you an output that says the specified service doesn't exist. And this is actually true because the service was already deleted right afterwards. So that's how Smb Exec works. So it executes a command, it creates a service, it pipes the command via cmd.exe, and then deletes it afterwards. So if you're not actually reviewing the event logs, you wouldn't actually see any artifacts. However, Smb Exec have some caveats or prerequisites. So for Smb Exec to work, you need to have a user account with high enough privilege. And of course, you need to have an open port 445 since Smb Exec uses the Smb protocol. And most importantly, you need to have internal network access. So actually, there's a lot of things required for Smb Exec. So you need to have internal network access. And for most attackers, they probably don't have this. This is like a heaven's door for them. And the question is, how do they open this heaven's door? So we'll introduce a tool called Ngrok. So this is uh, basically a legitimate tool that lets you expose your servers behind NATs. It actually acts like a VPN but in reverse. So it looks like this. So if Ngrok is running in your machine, your firewall and NAT would be useless, and the services within accessible within your machine is actually exposed to the public or to the internet, and anyone could access it via internet. So any machine in the network can be accessible, including your machine. And for Ngrok, network traffic is encrypted via TLS, and attacker can access the machine anywhere and anytime. And also, the good thing about, or the bad thing about Ngrok is tunnel traffic is not limited to SMB. So you could actually try to experiment with Ngrok. You could actually tunnel uh, RDP or FTP, HTTP, or other traffic that you want to tunnel.
So as Abraham mentioned earlier, if you have Ngrok, if you have one Ngrok instance in the environment, the other machines would also be accessible through that Ngrok. So for instance, if what it would feel like for the attacker is, say for instance, he wants to attack a particular machine, it would feel like he's directly sending commands to that machine. But in reality, the traffic is sent to Ngrok and to that machine with Ngrok, and it's routed to his target machine. So now what happens is the Ngrok is configured so that it sends traffic to the other machines. That way, the attacker has access to the rest of the machines in the environment. In this case study, we found 3 machines with Ngrok, and with those 3 machines, they were able to send commands to 35 or over 35 other machines. So it's not so bad. If we go back to the backdoor model, what you would need is if you want control to these 35 other machines, then you would have to copy the backdoor to these 35 machines, and that would definitely be noisy. But in this case, that didn't happen at all. Now, whenever Smb Exec is used, as Abraham mentioned earlier as well, so a service is created, and that service is responsible for launching cmd.exe, which launches the command that the attacker wants to perform. And whenever a service is created, a corresponding registry entry is also created. So this registry event is logged by our EDR product. And using all these registry events, we cluster them based on time and based on the specific steps that were taken to come up with the actions that the attacker did. So first, it tried to install the tspy in the environment. So this tspy is a straightforward keylogger and mouse click logger, sends everything over to a Gmail account. And we know that it's unique because the proxy server of the client is hard coded in that binary. And what we saw was they used Smb Exec to create the persistence mechanism of that tspy. So it basically created a reg add command, and that created the registry entry for the tspy. Now, the second thing that we noticed was how the attackers seem to be looking for certain files in certain directories, or files in certain directories. So we saw it because there was a series of cd commands, cd path, and whenever that change directory command is called, it went deeper into the directory structure until it reached a particular directory. That's the sticky notes directory. And then it would execute a directory command. So it would check the files within the sticky notes directory. We don't know exactly what they're after, but if you kind of match it with the tspy, they're probably looking for notes or data notes that are entered in the sticky notes program. Second, this is something that's close to a lateral move, but instead of copying a file over, the steps become a lot simpler. So in the beginning, they run an mscan command. So this is to check for IPs that have port 445 open. So they have these IPs that they know have port 445 open. And later on, if they want to execute commands in another machine, they just get that IP and they make sure that that IP is online by doing a direct ping. If it responds well, they configure Ngrok so that it now redirects the traffic to that IP. So again, no files are copied over. It's just a simple reconfiguration of Ngrok. Third, we saw that they tried to get user accounts. So I think we saw a couple of net user account / domain. So they're probably checking if a particular user account has domain access. And we also saw the tool fgdump executed. And then there's in some instances, they called PowerShell with a command line parameter that if you dissect it, becomes a shell code that downloads a binary from the internet and reflectively loads it in memory. Whatever it downloads could be anything. It could be Mimikatz, but what we noticed in one instance is it tried to download a backdoor. Well, if you think about it, this is still fileless, this backdoor. But instead of just having Smb Exec, they probably use some redundancy mechanisms, like in this case, a backdoor that's executed through PowerShell. And there are some other commands that they executed or actions that they've taken. And sometimes they need to check if a machine has access to the internet, so they ping Google, so on and so forth. So as mentioned before, for one to run Smb Exec, one has to have a high enough privilege user account. So based just on that, we know that this attacker has been sitting in that environment for quite some time. And second, they needed to install Ngrok. So this didn't happen overnight. Probably they've been sitting in that environment for such a long time. Maybe they started with your traditional backdoor and then graduated to having this particular setup where you have Ngrok and Smb Exec. And the difficult part for us is if we just saw a command executed and say, for instance, there really is no action that can be taken based on the info we have, like we do not know the account that was used to run the command, or we do not know where the command is coming from, it makes it hard to respond. So it just means that for every command that we see, we have to study it to find these particular information, to make our response relevant. So how did we defend it? So first, when we realized that there were some Ngrok instances running in the environment that wasn't supposed to be there, we asked our customer to uninstall those Ngrok instances. And we also asked them to block Ngrok traffic in their firewall just in case we miss some Ngrok installations. Second, we identify the compromised account and we ask the customer to update those accounts. So that will limit the action that the attacker could take. And to watch the environment, so we first looked at the registry, or we started watching the registry event logs, particularly registry entry keys that contain service. So that means it's a service registry, and the image path data containing the string comspec or cmd.exe. So this is a trademark behavior of Smb Exec. In this case, it fit them, so we needed to watch out for those commands. And the second is we looked at process events where services.exe launch cmd.exe. So again, another indicator that Smb Exec might be used, or they might be using Smb Exec. So Abraham, would you like to give a comparison between the two?
Sure, Gilbert. So for this case, let's compare the traditional backdoor shell versus uh, the one we found in our case study, Ngrok plus SMB Exec. So for the backdoor shell, basically you have the functionalities of being able to remotely control the host from the outside, and to the ability to execute a lot of commands. For most backdoor shells, probably you would be able to basically do whatever you like. Also, it has the ability to drop and execute tools. For Ngrok and SMB Exec, it's practically the same, basically. For the attacker field, commands are coursed through the CNC site when you use the backdoor shell. So there's a need to register a CNC server for you to use, and the results are taken from the CNC server. But for Ngrok plus SMB Exec, it's actually more of a direct access, since you could actually access the machine via Ngrok from anywhere. As I've said earlier, Ngrok is a service that practically opens your host and all the other machines in your network to the internet. As for the noise, for backdoor shells, of course, there are files, activities associated with lateral movement. There's also, if you want persistence, there's also registry artifacts like regrun registries, sometimes services, or sometimes in the startup folders. These are very typical of backdoor shells. But for Ngrok and SMB Exec, service registry entries are created only upon execution of the commands. Right after the execution of the commands, these are actually deleted, so there are no artifacts. If you don't have any EDR solution in place, you'd probably miss this one. And also services that exe launches the cmd.exe, since the service registry entry is using comspec, which is the default value for this variable is actually cmd.exe. So basically, that's it for the comparison of Ngrok and SMB exec versus the traditional backdoor shell. And actually, thinking about it, these tools are really very, very powerful just by themselves. And in addition, there are actually pretty much unlimited combinations of these tools, since there are many, many tool sets embedded within your system that the attacker can use without him actually having to develop another binary or backdoor shell. And Gilbert, would you like to add something to this?
So you mentioned um, it's not just SMB Exec. If you look at Impacket alone, there's a lot of other tools that you can use. There's WMI Exec, uh, there's RDP, and I think if an attacker uses this, he will probably not rely on Ngrok and SMB Exec alone. He will probably have a different or more tools
Yeah.
combined to carry out the attack. And having more tools means having more ways to get back in the system or execute commands in the system. And that makes it first harder to defend, and second, it makes them have a bigger or stronger foothold in the environment. Just in case one particular way fails, then they have another technique to use.
Yeah. And one thing about this that I think about is the attacker has a lot of choices depending on the situation. And as I've said, most of these tools are already available within the system without, of course, AV and EPP can actually detect those files since they are actually legitimate files.
Well, first, if you think about our particular case study, uh, the organization didn't really use Ngrok. They didn't have any use for Ngrok, and it wasn't one of those tools that's allowed in their company. But it was running. So having some kind of application inventory and having some kind of control to which applications are allowed to run in an environment would be very helpful in this case. If they saw ngrok running much earlier, then this would have stopped earlier. Would you like to say something about lolbasmer?
Yeah, I think we're seeing a lot of lolbus these days, and probably lolbus is here to stay. Probably is the new no, like the situation we're in. Probably this would be the new normal nowadays, since lolbus is very 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 powerful, and I can't think of a way to a foolproof way to really defend against lolbus. But I think having an EDR solution in place, and as Gilbert mentioned earlier, application and inventory control would somehow mitigate the risk involved in lolbus.
And the thing is, there are a lot of material in the internet, and there's a lot of talks done about lolbas. And the truth is, it's different when you read it, uh, and when you experience it. So even if there's an overflowing amount of material outside, it's important for security researchers to share what they know. And this is exactly why we're doing this. Because when it first came out, it was new. And we were fortunate enough to catch it and understand it. And so we hope that you got something practical that you can use in your companies, something that you can take back to help you defend against threats. So with that, we thank you for your time. Have a great
Thank you.
day.